Hi, my name is Chris Wilson. I'm the Director of Data Journalism at Time Magazine, and my talk, Data for Democracy, is about how we use Wolfram technology at Time to better understand the news through a computational perspective. Hi, everybody. My name is Chris Wilson. I am the Director of Data Journalism at Time Magazine. I am pretty sure I'm the first working journalist to ever attend the Wolfram Summer School, because on the first night I was there, one of the Wolfram employees, who will go nameless, took me aside and said, he seemed nervous. He said, if Stephen says, I'll never forget his wording, if Stephen says anything alarming, it won't go in Time Magazine, right? And I said, no, we'll consider this all 3 weeks off the record. But then for all 3 weeks, I was just sitting there thinking, what does Stephen know that we don't, that is so alarming? And I never found out. So, but anyway, I'm very proud to be a working journalist because there's so many things that are not right with the media right now. We all know. But that what we need is to bring a more kind of, to have as much of a kind of intellectual and computational approach to the news. We need people who think like that in every newsroom. And so people often sort of ask me, well, if you like computer science so much, why are you also in journalism? I see it actually as a wonderful marriage of two ways of thinking. And I was reminded of this when I was rereading Stephen's essay about Richard Feynman in his Idea Makers book, and talking about how much Feynman loved the process of figuring things out as opposed to just getting the correct answer to a problem. And that, to me, is very similar to the way that you tell a story, which is that rather than just telling somebody how it ends, you want to tell them how you got there. And so what I'm going to show today is how I used Mathematica to power this article that ran on Monday in Time, which is all about how many seats we should have in the House of Representatives. 435 is an arbitrary number we arrived at in 1929 after, endless sort of debates on who would get more seats and so forth. The reason I picked this example is that I think it's a good example of how Mathematica really lends itself to telling a story in the process of writing code, which is what really, for me, represents the union of the things I'm interested in, but also the sort of idea of a computational essay that Stephen laid out on Tuesday evening. So you certainly won't go through it line by line, but the most important algorithm, arguably ever, is the way that we decide how many representatives of the 435 go to each state. The Constitution is very, very vague on this. It says everybody should have one. Makes sense. There were only 65 to start with because there are only 13 states. And then other than that, it just says basically it should go according to their numbers, which is interpreted to mean their population, and that now includes everybody. We've tried 5 different algorithms for doing this over the years, and it's funny to think of lawmakers arguing over algorithms because most of them don't understand them, and yet still it's a very, depending how you weight who deserves to have how many seats, when it definitely doesn't easily round, is actually quite important. The way we do is we give everybody one, according to the Constitution. So we have 385 left. And then we give everybody a weight, every state a weight, which is their population divided by the geometric mean of the number of seats they have so far, plus 1, times that number plus 1. And then it's just this round robin. You just keep doing this, and as you're parceling out seats, you're recomputing the priority for each state. And so the first task here was to just recreate what is legislation as code, because that's what functionally legislation is. It's the source code of America, but it's often very vaguely or terribly written or impossible to understand without a law degree. And so I rewrote the function that for any number, not just 435, doles them out. I tested it on the number 435. I know it's not super easy to read, but it's not really that important. Point being just, it works in the sense that if you compare it to the actual number, sure. Does anybody know how to do that? Oh, yep, thank you. Okay. All right, so point being just, the first step was to make sure that I hadn't made a mistake by taking the actual number of representatives per state, subtracting it from the computed value, and making sure that they were all 0. That's just a sort of spot check. But here's where it gets interesting, is this is the number of, the ratio, the number of people per representative in every state, which ideally the variance should be 0. But we have Montana on one side, which has almost 1 million people as of the last decennial census. It now has over 1 million. It has 1 representative. And then you have Rhode Island, which has only about 3% more people than Montana, but got 2 seats instead of 1, and so it's got about half the value. And what it really comes down to is just there aren't enough seats, that somehow Rhode Island was just a little higher in the priority list than Montana. Probably Montana would have gotten a seat if there had been 450. But that's why the system is broken, is that we're using this arbitrary number that we decided on almost 100 years ago. But so what was fun about this, and where we get into sort of the computational side, was to say, okay, let's just imagine what the variance would look like for a number of seats, starting at 435, where we are, and going up to 1305, which is just 3 times as many. And then using as the dependent variable just the coefficient of variance, just very simple measure of how equal that bar chart looks. And it was really interesting that, of course, you expect the fairness. So if you think of a lower value here, it's just being more fair in the sense that states, there's a more equitable distribution. That of course, you expect it to go down as you get more seats. It would be very alarming if it didn't, but it's not remotely linear. And there are these strange junctions. It's not contiguous either. And so this became a fun kind of investigation over why is the House kind of, why is 435 kind of broken? So this is just the exact same graph, but just identifying green points are like the optimal values, and red points are the worst possible values, such that if you add 1, the disparity drops enormously. And then looking at so these numbers up at the top are just those green values. And looking at who gets the last seat in this round robin process and who would have gotten the next one if the number was one larger. So first, when you look at the optimal values, you see that they're all very small states. Montana, Delaware, South Dakota. Those are all states, just off the top of my head, I'm almost certain, that currently only have one representative. And they're getting, depending on how many seats you give them, either 2 or 3. Whereas the next one, if you had one larger, goes to a large state. So we actually do see that poor Montana would get its second lawmaker, which it deserves given the population, if there were just 5 more seats, 440. And you know, we can see that here in that the disparity dropped significantly after just adding a couple of seats. This is the same chart I showed you, just looking at some of these different optimal values. And what's curious, and we can see this from the chart, is that 930 is this sort of magic number that is, the variance doesn't get that much better when you add another 300-ish seats, but it's only a little bit more than twice what we have now. So this is the premise, that this is a computational investigation, journalistic investigation that comes up with a premise that I think is defensible, and many people who have tweeted at me do not think is defensible, is that we need 930 members of Congress. This was how things worked until 1929, where as more states were added, we'd always add more people. The population of the country is more than 3 times what it was the last time we added any members of the House. Then just for fun, I also ran it for 5,000 members just to see, and you see the variance comes down to 0.01, but that's probably not a realistic scenario. It's just kind of curious. And so what I was able to do then was write an essay that, these are all graphs you've seen before now, just rewritten in JavaScript for the browser, that is making the beautifully written, is making the case as best I could to an audience slightly different than, say, this one, laying out why we need 930 members of Congress. And I'm not kidding when I say plenty of people were nonplussed, would be a polite way to to say this, but that it's something that I think people often sort of don't think about. Many people were just surprised to learn that 435 isn't a number in the Constitution. It doesn't even require an amendment to change. It's just a law. And so Congress actually gets to decide how many seats there are in Congress. And so it's quite easy to change and is overdue for a change, but it required taking a problem that and thinking about it computationally, which is really what I want to emphasize in order to come up with what I think is not a bad little piece of journalism. Feel free to disagree. My Twitter handle is Chris Wilson DC. But just to sort of belabor the point a little more, the way I can formulate these types of essays is by essentially writing them in a notebook first, and making very deliberate use of the formatting to give it a title, and kind of just work through argument. So there's a lot of those words in here of no computational power. But this is something that I do even if I'm not presenting a notebook to a group. I might not spell check it quite as well, but I write out what it is that I'm doing and the reason for it. Essentially, just making liberal use of comments in any other coding language, and it's just really nice in Mathematica that you don't have to put all your notes between parentheses and asterisks. And so this is both on the cloud and uploaded on a somewhere. But you're welcome to look through it if you so desire. But it's basically just laying out very much what's happening and why. And that gives me a template for how to make the argument, the exact same argument in an essay for a truly great American magazine. And I say that not because, I don't know if it's live streamed, if my boss is watching or not, but very, very, very unlikely. But it is a wonderful place. People often ask me why, if, again, I like coding so much and going to the last standing weekly news magazine, and I say that it is the most ethically pure example of journalism I've ever seen, where we are so intent on being fair, being nonpartisan, and reaching as many people as possible. Not just because you don't want half of your readers unsubscribing, but because you need to reach everyone. And if you can't reach everyone, then you're not doing something right. And that it actually is a fairly nice marriage. I have one or two other examples, but let me. Great question. There's another function in another notebook somewhere that does this, and not much is the short answer. I live in DC, and we have about 730,000 people who live physically in the district, which is larger than the state of Wyoming. I think that would be, it's roughly smaller than Delaware, larger than Wyoming. And so we and Puerto Rico as well would be sort of towards the end of the priorities and probably get one seat under the current allocation. That seat would probably come from North Carolina, I think. I think they're the last one in line right now. And I should also say that another thing I did was, this directly informs the size of the Electoral College. Just add 2 to every number. And there wasn't a single scenario that changed the outcome of the 2016 election, even when there are 2 states, Nebraska and Maine, that split their electoral votes by congressional district for the, and then give the 2 belonging to senators to the statewide winner. Even if you sort of try to simulate that, nothing changes because the winner-take-all system of the Electoral College makes it really kind of trivial when you increase the size. So this is much more about having a sensible representation as opposed to changing the outcome of elections or anything like that. Well, so that would require a constitutional amendment. And that would require, I think, kind of a reckoning of do we deserve to have a body that is more powerful, that is agnostic to population? And I'm not certain the answer is yes, but that is a core principle that was decided upon by 1789 and I think is fairly unlikely to change unless you came up with some way that you sort of weighted people's votes differently or something. So it's really kind of my non-answer is, let's fix the House, see how much better everything gets, and then apply to the Senate. By all means, I mean, the question is basically, how do you legislate computation? And if it were me, I would say, I mean, you can't really upload a notebook to the legal system, but you could come up with a way to describe this approach where, when we were looking at the optimal values here, the reason I chose 930 was not because it's absolutely the best. 930 is right here. Is because it just is close to the best. It's the fewest people you have to add to get to what resembles the local. If you think of the green dots as local minima, then you see it's basically the smallest value that gets you the biggest return. I'm sure you could parameterize that some way. For sure. Absolutely, because the census publishes fairly reliable state-by-state demographic projections. They're pretty good up through 5 or 10 years, and then they go through 40, and just is impossible to say. But yeah, no, they don't know about the aliens. But you could certainly, I mean, you could even do something even simpler, which is just look at the vector from the previous decennial and say, okay, you grew this much in the last 10 years. Let's assume, you're heading in that same direction. But that is less important to me than figuring out a way to say, basically how to defend the fact that 930 is the best. But I'm sure we could come up with something that you could either say any number less than 1,000 or just some ratio of the number of seats you'd have to add versus the benefit you get from it, and you optimize that value. What prompted me to attend the summer school? So I've been coding for about 10 years. I'm self-taught. I have no credentials. But I saw a video about the release of machine learning algorithms in Mathematica, which I had never heard of before. One of the things that Mathematica really needs better representation in my industry and industries like mine, which have nothing to do with science and arguably sometimes antithetical to it. But that because I try to teach people, I offer a optional class for all of our interns on how to learn to code, just because it's good job security. Usually they only attend the first session, but we're doing it in JavaScript just because that is the only option right now. But it's really hard to get them to understand why they should want to know this. Whereas if I could have them all running Mathematica, then you just get to see the product of your work so much faster. And so I was really, really intrigued by this whole concept. And I heard of Stephen, but I didn't know a whole lot about him. So I actually was going to write a story on it. And they connected me to Taliesin Benson. And he's like, why don't you just come to summer school? And he ended up being my mentor. And he's a great friend who doesn't respond to a lot of email. But it's 3 of the most rewarding weeks that I can think of off the top of my head. in the recent past, just because people around work were describing me as, "Are you going to space camp?" And I was like, basically. But just I kind of felt like I'd found my people, and I would love to go back sometime when I've accrued enough good enough moral points to once again disappear for 3 weeks. But thanks, Vitaly. I know I'm not supposed to be up here anymore, but I'm going to show you this is just a preview of something, that's the wrong one, that is forthcoming, which is that I'm really interested in trademarks, because they're this window into anybody who tries to register anything as a trademark. It gets put up on a very poorly designed website run by the US Patent and Trademark Office. But it's this window into how people think about marketing. And so one funny example is how people try to take an existing slogan and make so. These are we found 300 examples of people who had registered a trademark since Donald Trump first did. That was just make X, Y again. That was the only thing you had to you didn't have to have either America or great. But anyway, but this is a real thing. I mean, FCA network, whoever they are. So the thing I'm looking at now is how precise, you can choose to say that color is or is not part of your application. It's harder to get approved if you say color, but it's also a very arbitrary process. But you see these things like, this is a masonry company in Des Plaines, which is at least in the same state as we are now. But I think it's pretty obvious that they are trying to invoke sort of Starbucks there. You can argue with that, but the colors are certainly very close. And so I took everybody that mentions the word green, used a bunch of stuff to basically reduce from the 16 million possible values in RGB, and came up with, this is sort of the final product of all the greens that are trademarked, and by frequency with some clustering, and so that'll be forthcoming. But you can see some of the examples there. Thank you so much. I'll be hanging around.